session number 4, Locomotive Research number 2, and my name is Ryo Amano from University of Wisconsin at Milwaukee, and I'll be the chair. Now, without much delay, we would like to start with the first paper. This is a common rail system, will be presented by Mr. L.M. Naik, who is a senior general manager and working in the Bosch for 2 years on diesel system development. And he has been very active in these areas with large and 13 and new era for common rail system in India. So with this, Mr. Naik.
Thank you.
Also, please keep your presentation roughly 20 minutes, and I'm going to give you the notes.
Good afternoon. Am I audible to the last person? Okay. First of all, I should be thankful to the organizers for giving the opportunity to Bosch to deal with one of the latest talked subject, which is common rail system for the large engines. I hope all of you know very well when we talk about the diesel, and we call in Bosch diesel systems, and it is a diesel full liner. When we talk here, it covers from 4 kilowatts to 40,000 kilowatt power. At the same time, you can see it can start from a single cylinder to 20 cylinder. This is the kind of diesel engine we are talking. And coming to the Bosch experience, you can see diesel systems produced 1 million products for this purpose daily. That is the kind of volume we are talking. And when we ship to the today's focus, the large engine, you can see this large engine application can be divided into 4 major areas. One is the stationary applications, where we talk about the genset and emergency power generators. It may be used either in sea or in industrial applications. Then comes the marine applications, where we talk about the ship, and here the applications are, it can be ferries, and again you are also using generators in the ship. And the third one is more of an mining and industrial application, where we talk about the construction vehicles, the mining vehicle, and the agriculture vehicles, where it is usually powered by quite large swept volume engines. And the last one may be quite interesting for today's one is the diesel loco. Now I straight away come to the topic, because the time is quite less, and we are going to talk brief on some of the products which we are already using and which will come in future in this locomotive and large engine applications. So we have 3 things which all of you know. The first one is based on the single cylinder application, where usually we call it as unit pump system. Points. One is the unit pump system, which I was talking. It's more related to single cylinder pump. The second and third one is more related to a common rail, where we are talking about the first one is the more on the 1600 bar, and further is 2200 bar, which we are also looking for this kind of new applications. Coming to the first unit pump system, as I am telling you, this is the single cylinder pump. What is new here is, you can see this has got the solenoid switch on the pump, and the injector is purely mechanical. The advantage of this is you can have a variable start of injection. At the same time, you can control the injection quantity and the injection begin. So based on your application, you can try to modulate these systems, and purely the injector design depends on the nozzle geometry, the spray angle, and the injection pressure, which can be changed according to your applications. This is how it looks like as an individual pump. You can see this is the plunger and this is the solenoid valve where it can connect and disconnect the high pressure side systems, and you can vary the start of injection. Now we will look at the first stage of the modular common rail system, where we talk about using these single cylinder pumps, but here this number of single cylinder pumps will not be equivalent to your number of cylinders on the engine. Ultimately, the requirement of this is decided based on how much quantity you are going to use and how this total injection quantity you are going to divide based on number of systems, number of cylinders. So you can see it's a fuel tank where you have a supply pump which pumps the fuel into the fuel filter. Then you have a kind of inlet metering where we usually control how much quantity used to go inside these two unit pumps, so that the total efficiency of these pumps before pressurizing it can be totally utilized, so that only compressed fuel will go to the common rail, and common rail is an accumulator system where the injection pressure is also measured at the same time as an emergency. In case of if you have to leave out the fuel back to the tank, you have a max pressure valve also. We call it as pressure limit valve, and you have an injection pipe which connects the rail to the injectors. That means this rail is used as a common accumulator. From there, the high pressure pipe will go to a different number of injectors based on number of cylinders you are going to use, and it is purely electronic diesel control where ECU is used, and minimum two inputs we need. One is the engine speed, another is the cam, because we have to correlate crank and camshaft relationship on these engines. And this is the first modular system where you are using an engine which is the single cylinder pump based, and we have to adopt the inlet metering system to that. And if you look at these components, you can see we use an single cylinder pump, then we use the common rail injector which is derived from our CV or a large engine market. Then this is the fuel metering unit, which is one, and these are all the T joints which we connect all the injectors, and this is the ECU. So usually this is used for the off-highway diesel engines, and we can see number of pumps what we use here based on the quantity. It can be 1 to 3 maximum. Now I am talking about the most modular common rail system, where we are imagine you have an engine where the FIE and the engine coupling is like a direct. That means it is not like a single cylinder pump, and you can directly couple this main pump, and this main pump has a gear pump which usually sucks the fuel from tank, and from the tank you have a filter, we call it as pre-filter, and then the pre-pump which we usually use it as a gear pump will supply it to the main pump, and in the main pump we have this inlet metering control device, and whichever is required it will be compressed through this pump, and it will go to an accumulator. I can see a common rail which is a part of this pump, and it is not a separate, and you have also a pressure sensor here. At the same time you can see there is also a max pressure valve, which is always used to release the pressure, and this is now directly connected to the injectors, and these injectors can be based on number of cylinders you are going to use. And again, it is a latest electronic control unit which has all the governing functions, and it has more flexibility when we talk about engine control. So when we look at the major components from this system, you can see we call it as a pump, where the small single cylinder pumps are accumulated or assembled based on the total requirement of the engine, and a small integrated rail is also there, and where the pressure sensors are connected, and the whole pump you can couple it to the engine. And the injector is entirely different, where we talk about a kind of a volume, because we are not using the total rail. Instead, we are using the dead volume of high pressure pipe, and we are also creating a dead volume in the injector so that it can work as a rail, and solenoid is located very near to the nozzle, so that controlling the injection characteristic will become quite faster. And this is most robust, and it has been tried, and you can see here this is fully modular, we call, because the controlling parameters are quite high. And this is the ECU, and MCRS uses usually high volume engines also. That means multiple applications it is being used, and at the end it can be used for off-highway as well as the locomotive applications also. So coming back to the customer benefits, it's, I can say, almost common benefits of the normal common rail. One is the independent of engine speed. The second one is the noise. Definitely operating noise will be lower, and as we are operating to the requirement of the engine, full load, part load and idle, fuel consumption can be targeted, and if you are going to apply emission limits, we can apply the injection timing, and we can also bring it down. And definitely this is proven, and it has the long lifetime which is required for off-highway applications, and it is totally validated. Now coming back to more of a summary of the total products what we have produced and which we are going to produce in this large scale. You can see we have the conventional large engine where we use the mechanical pumps. We have the injectors, we call it as nozzle holder assembly combinations, around 600 varieties. Out of that, a lead I can say 120, and here the sizes you can go maximum injector length to 600 mm. And we have PE and FM type of inline pumps, and PF pumps, which is nothing but an mechanical unit pumps. And you can see unit pump system where pump has this solenoid valve is also comes under the category of conventional, and this is, I can say, robust, which is already produced, being used in the worldwide, and most of the railways also it uses. And common rail as a large, these are all the two types of pumps, and this is the injector which I showed, and based on the height of the cylinder and the location where nozzle has to reach, we have variable sizes. I can say it starts with 150 and it can end up to 750 mm of length based on your requirement. Just to show you where all these parts comes, definitely it does not come from Bosch India with all the parts, but it will come from variety of locations based on the applications it is being used. Farmington Hills, we have unit injectors, nozzles and reman products, remanufactured MCRs also, and Austria Halline is a major source of such kind of large engines, and in India, in Bangalore, we usually focus on mechanical unit injectors and the PF type of pumps, and at the same time conventional nozzle holders also. Just to give the last slide of my presentation, in India, Bosch has a very high presence. You can see when we talk about the small single cylinder engine manufacturing, development, parts to, I can say as on date, 12 cylinders, we have all the facilities, nationwide dealers, the repairs, at the same time manufacturing locations are also filled in. If I have to make it clear, 6 companies, 11 manufacturing plants, around 1,500 suppliers, 4,000 sales outlet, and around 26,500 employees. It's a very large network. I can compare it to the rail network of India, so that we are there everywhere where the rail goes. With this, it is a very short presentation. Definitely we can organize a detailed 1-day, 2-day, 3-day program based on your requirements, based on the project requirements, where our experts can come and discuss with you to the thread details. Thank you.
Thank you very much. Okay, we have some time for questions. Anybody have a question? Yes.
Tested this on some mission. Have you tested your...
Yeah. In case of large engines, in European applications, we have tested, not in India, but in common rail also it has been tested.
Or would you be requiring modification to the combustion chamber, piston geometry?
Actually, when we started common rail in India, based on the customer requirement, there are some cases where we have not changed. Existing piston geometry was well fitted. There are some cases where we have to change because their requirement on emission and combustion pressure and distribution was quite different. So based on your requirement, we can analyze and we can tell you whether such a change is required or not. Both the cases are available.
Okay, thanks.
Yeah, I think it also depends on what is the starting design.
Yeah, you are right.
Can I ask you?
Yeah, please.
So this is about MCRS 16. So you showed 2 pumps are enough. Are they enough to supply for an application like locomotive, which is like flow rates of 600 to 800 kilograms per hour?
Actually, we have a calculation called quantity balance, where we require your rated speed and total injection quantity and the pressure what you want. Based on, we usually calculate the pump capacity. It will lie between 2 and 3 pumps.
Okay. So another question about this is how much is the injection delay in such large injectors which are typically used in locomotives? And are they capable of doing multiple injections like pilot injection and post injections? Because if you are not doing that in common rail, then it's not very good.
When you are talking about the MCRS, where I have told the 1600 and 2200 with the solenoid valve injectors, the multiple injections are possible. If you are using the single cylinder pump with a solenoid valve in it, with a mechanical injection, multiple injection is not required, not possible. And the delay, whatever is the delay, it can be compensated in case of common rail through the common rail pressure governing concepts. We can take it out.
The other question is, you have shown architecture of the common rail direct injection for typically for locomotives. So I would like to ask you, how much different it is from the automotive. Is there any special provision in this compared to automotive? And how different is your ECU compared to the automotive ECU?
If you really look at the automotive components, we correlate it to kilometers covered in a lifetime. Okay, but when we talk about the large engine, it comes to the robustness of the large engine, and it will meet your large engine expectations, especially injector and pump and ECU. These three components we have modified to suit your requirements of lifetime. It will meet your large engine, and it is entirely different from your automotive applications.
I was talking about the architecture.
Yeah. If you look at this and the dead volume in the injectors, that is very much dedicated to large engines, because we are not, in case of automotive applications, we use a rail in between to fulfill that dead volume. But if you really look at the locomotive, because your pipe lengths are so high, we want to compensate this dead volume in these pipes. And we are also giving the dead volume here so that we can compensate the needle movement correctly. That is the new thing which we have adopted in the large engines. And definitely it is a slow speed engine compared to the high speed engine of the automotive applications.
Is there any plan to bring piezo into it?
So far, no.
Any more questions? Okay, if not, we would like to thank Mr. Mitchell.
Naik.
Naik,
Yeah.
Mr. Naik.
Thank you very much for giving us an opportunity.